Okay, inverse function of quadratics. So I've done this off the top of my head. I have what I hope is the same quadratic, but written in two different forms. This one is known as the standard form. I really should have double checked this before. And the first one, number one, is actually called the vertex form. And this one's really important. It makes it easy to find the inverse of a quadratic. Otherwise, you end up with a scenario again like this, and this becomes very tricky to isolate for a while. You actually have to do something called completing the square, which we may not have talked about yet, so we'll come up with another solution, kind of like a workaround to solving it. What we're going to do is we're going to bring up a graphing calculator here. Okay, I'm going to bring up our graphing calculator. There it is. And we're going to represent these two on the left-hand side. So instead of writing f at x, I can always write y is equal to. It's just a little trickier on Desmos to write f at x, so I'm going to continue with what we have here. Y is equal to 3 bracket x plus 2 n bracket squared minus 5. Okay. And y is equal to 3x squared plus 12x, oops, 12x plus 7. Oh, thank goodness. Okay, if you notice on here, these actually represent the same equation. It's just a different form, okay? What we're going to do is we're going to look at the blue form, okay? And that's the standard form here. I guess we'll kind of try to color code it. Our standard form we have currently in blue, and our red version here, well, that's our vertex form. I'm going to show you by putting into a graphing calculator some key points. Can I draw on this? Oh, I can. That's great. We're going to use some of these key values to build the vertex form graphically, and then we'll go through how to turn that into an inverse function. So looking at this here, the vertex, which is actually really important for the vertex form, we need to know what that value is. In this case, it happens to be the x value of -2 and the y value of -5, okay? That's really important. That actually helps us for vertex form, okay? Because the parent function of vertex form, let's say, we'll call it f at x again, and this is, we'll do it in, I'll use the red to kind of relate it. We're talking about vertex form right now. Actually, sorry. Let's relate the standard form here. The parent function of a standard form is a, oh, what happened there? A equals f at x. F at x is equal to ax squared. And you're going to need to know this eventually, so it's kind of like jumping ahead a little here. Plus b at x plus c. Okay, that's the parent function for standard form. Where the parent function of the vertex form is a at x, commonly minus h is the term used, plus k. Now, I want to point out here that b and h, not the same variable, not the same letter, so don't represent the same number. C and k, not the same letter, they don't represent the same number. But the a value here, that's the exact same. So when we're taking something from standard form to vertex form, I can take whatever the a value is and plug it right into the vertex form. So we'll say f at x is equal to, and in this case, the a form in standard is 3. So I know that the a form in vertex will also be 3. The next part that becomes a little trickier is the h and the k. Luckily, we have the graph of this. So from the graph, we can pull this information out. The h value is actually the x value of the vertex, sometimes represented like this. That's the x value of the vertex. And the k value is actually the y value of the vertex, okay? So if you notice, the h is actually -2. So when we go to plug it into the vertex form, we end up with 3x subtract, and it's -2 we subtract, okay? Which is going to be important because that will show you how we got the original answer. And the k value in this case happens to be -5, right? There's our -5. So we're going to plug -5 in for k. I'll write the rest in black so it's a little easier to see. But we're going to simplify in those brackets there. We end up with 3, and x minus -2 is the same as just x plus 2. So we can say x plus 2 squared minus 5. And if you take a look, that's the exact same thing we got here, Okay, we got that 3 open brackets or open parentheses x plus 2, close parentheses, power of 2 minus 5. Great, so we've turned it into vertex form without doing what's called completing the square, which is a whole nother process. And the reason we were able to do that is because we had some important information here. As a side note, these are both x-intercepts, okay? There's 2 roots in this case, and this is the y-intercept. The y-intercept is easy to see from standard form. Oh, I erased all of that work somehow. Can I bring it back? I'll have to get rid of this stuff. There it is. No, let's go back to it. Okay, sorry about that. Those are the x-intercepts. That's the y-intercept. We'll just put x's and a y here, okay? Important to know. To find the inverse. What's really good about this is now we have one variable of x. This is where we can start working with our inverse of the function.
Yeah.
Oh, don't disappear on me. Come on. Okay, sorry. Let's go back. I'm not sure why things are just... There we go. Grouped. Okay, so we're going to find the inverse. So we want to find f prime x in this case. So like we talked about before, we can rewrite this as y is equal to, and we're going to substitute y in for the x value. In this case, we'll write it in green, plus 2 squared minus 5. Okay, zoom out a little again. Okay, we're going to replace this. X is equal to 3y plus 2 squared minus 5. Okay, now we just have to isolate for that y. Luckily, there's one version of each variable, so this is doable. We'll just start moving things from the right side to the left side of the equation. That negative 5, when we move it, think of it like we're adding 5 to both sides of the equation here. So we'll end up on the left side with x plus 5. And on the right side, we still have y is equal to, equal to 3 times y plus 2 squared. Because this is multiplied by 3, we're going to divide both sides of the equation by 3. We'll end up with x plus 5 over 3 is equal to y plus 2 squared. Okay, and just because we're running out of a little room here, I'll kind of jump up to the right-hand side. Here, what we're going to do, I'll rewrite it up here, x plus 5 over 3 is equal to bracket y plus 2 squared. Now, because that's squared, we actually want to find the square roots of both sides of the equation. When we do that, on the right-hand side, the square root of this will give us y plus 2, okay? And technically, okay, on the left-hand side, you can think of that as this is a root function, x plus 5 over 3. And there's both a positive and a negative answer to this. Because when you square root something, you can both have the negative and positive version of something. That's going to be important when we go to graph it. We'll show it on the graph one more time. Finally, the last step, I won't write the plus or minus, the plus and minus sign in again. We'll try to simplify it by just the root here, x plus 5 over 3. And it'll become minus 2 because we're moving that positive 2 to the other side of the equation is equal to y. So essentially your function or your f at prime x is equal to the root of x plus 5 over 3 minus 2. Now, we're going to jump back into Desmos, see if I can zoom in without deleting everything. I don't think I did. Pretty sure I deleted everything. That's brutal. I don't want that to delete. I need those numbers. There they are. They're all over. I don't know why that happened. Let's see if I can just click into Desmos. I cannot. It's a very finicky program. I'm gonna... It's all over the graph now. Okay, let's bring in another Desmos. See if we can actually do that. There we go. A little inconvenient. Let's write our new function in here. Y is equal to the square root of x plus 5 end bracket, divided by the number 3 minus 2. Now this is what was important here. If you notice, because it uses function notation, okay, it only drew the top of the curve. But if I give it, I think I can give it a plus minus symbol. It doesn't quite allow me to do that. If I write it, the original function, I'm going to try this. X is equal to, when we first inverted it, how did we write it? We wrote it as x was equal to 3y plus 2 power of 2 minus 5, I believe. There we go. And you can see the entire function in there. The reason it was only drawing half is because when we talk about function notation, we talk about passing the vertical line test. And this one doesn't. So to make it a function, they essentially drop off the bottom part. But when we square root something, there's both a positive. This is the this is a representation of the positive version. And if I put a negative in front of it, that would be the negative version. And together, they end up with this sideways looking parabola. That's the inverse. And think about it, it's been flipped on that x, y axis, okay?